Good afternoon, students. Today we will discuss about the mixed second derivatives with respect to partial derivative. So already before going to this, already in the last classes we have discussed about the concept of partial derivatives of a single variable and two variables, and for more than two variables. Now, what will happen in mixed second order derivative? It is possible to carry out a partial differentiation of f of xy with respect to x, followed by a partial differentiation with respect to y, or vice versa. So clearly the results are examples of mixed derivatives. So it is must be careful for us with the notation here. So what is the notation of the mixed second order derivatives? So for that we use del square f by del x del y to mean differentiation of the first with respect to y and then with respect to x. And again we use del square f del y del x means what? Differentiation of the first with respect to x and then with respect to y. That is clearly from this explanation what is the notation of the mixed second order derivative is del square f del x del y, that can be written as del x of del f del y, and del square f del y by del x is equals to del y of del f del x. Means for both cases, while you are going to find a mix of second order derivatives, first you have to differentiate. Take the partial derivative of f with respect to y and x separately. So this explains why the order is opposite of what we expect the derivative operates on the left. Okay, so a clearly example is given here to give the idea of the mixed order derivative. So example 7 demonstrates that given f of xy equal to x cube plus twice x square y square plus y cube. So to find the value of del square f by del x del y. So first what you have to do, for finding del square f del x del y, you have to equal to del x of del f del y. That means del f del y you have to find out first. So how can you find del f del y? Del f del y from here is del f del y means partial derivative of f with respect to y, keeping x as constant. So whatever the terms of x in f of x y are regarded to be constant. So del y of f equal to del y of x cube, that is 0, because we are taking the partial derivative with respect to y, plus twice x square is a x term, so this is to be treated as constant, so it should be coming outside. Del y square of del y of y square equal to twice y, plus del y of y cube is 3y square. So finally, what is the value of del f del y? Del f del y is nothing but equal to 4x square y plus 3y square. Now after getting del f del y, again you have to take the partial derivative of x, partial derivative of del f del y with respect to x, keeping y as constant. So del x of 4x square y is what? Del x of 4x square y is 4 y is a constant coming outside, so del x of x square is twice x, so that is 8xy, plus del x of 3y square is 0, because we are taking the partial derivative with respect to x. So finally we got the value of del square f by del x del y is equals to nothing but 8 of x. Okay, then the remaining possibility is to differentiate first with respect to x and then with respect to y. That is, you can find the similar result of del square f del x del y by taking the differentiation first with the differentiation with respect to x first, then again with respect to y. That is nothing but del y of del f del x. So for the function in this example, what is the value of del f del x? Del f del x is nothing but 3x square plus y square is constant, so 4xy square plus y cube is 0, so 3x square plus 3x square plus 4xy square is the value of del f del x. Again, to find, in order to find del square f del x del y, you need to find del y of del f del x. So del y of del f del x is what? 3x square is 0, so 8xy is this. So clearly we can notice that by whether taking the first derivative with respect to x or first derivative with respect to y, we will get the similar result. Okay, so notice that for this function del square f del x del y equal to del square f del y del y del x. That is, the per mixed derivative is same for both the functions. Okay, then this equality of mixed derivatives is true for all functions which you are likely to meet in your studies. So clearly, for any function, del square f del y by del x equal to del square f del x by del y. To evaluate a now next is to evaluate a mixed derivative, we can use the alternative notation also. So to evaluate del square f del x del y, we write f of yx within bracket x comma y to indicate that the first differentiation is with respect to y. Similarly, del square f del y del x is denoted by f of xy within bracket x comma y, which indicates that the first differentiation is with respect to x. One more example to find the mixed order derivative at a particular point. Suppose you are going to find out f of yx at 1, 2 for the function f of xy equals to x cube plus twice x square y square plus y cube. So the solution is very simple. That means you have to find the mixed derivative for the point 1 and 2. That is, the value of x is 1 and the value of y is 2. So first find out del f del x. So what is del f del x? That is nothing but 3x square plus 6 4xy square. And then finally, after getting del f del x, you will find del square f del x del y by taking del y of del f del x. So del y of del x is nothing but f of yx, which is equals to 8 of xy. It's clear. So in the function f of yx equal to 8xy, you have to put the value of x equal to 1 and 2 to get the value of f of yx at 1 and 2 is equal to nothing but 60. Then we will I want to give you an example for finding fxx at the point 1 and 2 and fyy at the point -2 and -1, and f of xy at 3 and 3 for the function f of xy equals to x cube plus 3x square y square plus y square. So f of xx means what? Del square f del x square. So first find del f del x. Del f del x is nothing but thrice x square plus 6xy square. Again, del square f del x square means what? Del x of del f del x. So if you take the partial derivative with respect to x for the function del f del x, you will get that is 6x plus 6x plus 6y square. Okay, so the value of del square f del x square at the point 1 and 2 should be 6 plus 24, that is nothing but 30. So similarly, what do you mean by fyy? Fyy is nothing but del square f del y square, that is second order partial derivative. So for that you have to find first del f del y. So what is del f del y? And that is 6x square y plus twice y. Then again you have to take the partial derivative with respect to y. So that is nothing but 6x square plus 2. So what is the second order derivative at the point -2 and -1? You have to put it over here. So 6x square plus 2, that is 6 into minus 2 square plus 2, 6, that is equals to 26. Okay. Next, similarly, you can find out f of xy within bracket 3 comma 3. So for that you have to find out first del f del x. Del f del x is nothing but 3x square plus 6xy square. Then you take the partial derivative with respect to y. So that is 6x square, 6xy square, that is 12xy. So 12xy, so 12 into 3 into 3, that is 108. So this is the value of f of xy at the point 3 comma 3 is nothing but 108. So we will next move to the next part. So before going to the next part, we will want to discuss that whenever you are going to find out the partial derivative, whether it is for the first for a single variable or two variables, keep one thing on your mind, that suppose whenever you are going to find out partial derivative of a variable, you have to take the other variable remains constant. Similarly, if you are going to take the partial derivative of the particular function with respect to the other variable, you have to keep the first variable as a constant. Same cases will arise for second order derivative as well as the mixed derivative also. So up till this we will discuss the definition of partial order derivative, then its basic applications, and partial order derivative for a single variable, for a double variable, then second order partial order derivatives, and then mixed order derivatives. So next class we will discuss about the application of partial order derivative in some engineering based problems. And for today we will wind up our class. Thank you.